Right, this one starts off very similar to electric power questions in the start, and the first question is about electric fields. Magnetic fields. So what we've got here is we've got a circuit which goes through a solenoid, which is just coils of wire, and they've asked us to draw 3 magnetic field lines and draw the arrows. Alright, so first we've got to work out which way does the current go. So current always goes from positive to negative, so the current's coming out here, goes around under the loop and over the back here, around this is the top of the loop, comes over and down and out here. So that's our current. I'm going to draw our field lines in red. First I'm going to draw my hand in blue. So the way we work out the way the field is the right hand solenoid rule. Where in this one we've got our thumb as last, but our fingers, they follow the current, and then our thumb points to the North Pole. So if I was to grip this with my right hand, the only way I could grip it would be that my hand, here's my hand and my fingers are coming over like this. And my thumb would be that way. That's how I grip it, so that my fingers follow the current around. Okay, if I grip it the other way, my thumb was pointing the other way, my fingers would be going the opposite way of the current. So this way is the North Pole. After we've done that, a solenoid has the same magnetic field as a bar magnet. So a bar magnet with a north here and a south here, the field comes out of the north and into the south. Out of the north into the south. So that's what we're going to draw. Says here indicate the magnetic field produced both inside and outside the solenoid. Because we can see inside the solenoid, we can draw these lines all connecting. So we'll draw the one that goes, I'm going to draw it dotted so they can see it goes through. That's the first line that goes out of the north and into the south. And then this one over here. Goes out of the north and into the south, and another one around here. Here we are. Alright, now I'll just cut and paste this all into one page. So I've actually got the diagram that I've got next on your page is at the bottom, and then I've got the next page with the questions up here. So I'm just going to look at the diagram what they've given us. They say now that a loop of wire is placed inside the solenoid. So remember we had our magnetic field lines was going through here like this. They give us the sides, the lengths. The wire has 3 turns, that's N. Current of 4 amps, that's I. And magnetic field strength of this, B. The first question, excuse me, is what's the magnetic flux threading the loop? So flux is given by BA. The other way to think about it is the field lines cutting the area. The field lines going through the area. Now in this case, because the field lines are going through along here and the area is parallel to the field lines, you don't get any flux at all. So the answer is 0. And you have to give it a reason for your explanation, because area and field lines. Make sure you don't write because the area and the flux lines, because the area and the field lines are parallel. Right. Draw an arrow on figure 2 to indicate the direction of the force on side PQ. So the force is the right hand slap rule, and if we look down here, for our right hand slap, our fingers go in the direction of the field, our thumb is in the current, and our palm equals the force. In this case we have our fingers coming out this way, and this current goes along here, along here, along here, and down that way, so down towards me out of the page. So the thumb is that way. If you're holding your right hand like that, this is your fingernail, this is the top of your hand, and the slap is downwards. So our answer for this one is a downwards force arrow. That's that one done. What's the magnitude of the force on side PQ? This is a force equals N Bill, and we've been given everything down below. N is 3, B is 5 by 10 to the minus 2, I is 4, and the side PQ is 4 centimeters. Make sure you put 4 centimeters into meters. And when you do that on your calculator, you get 0.024 newtons. And last question in the set, what's the force on the side QR? Explain your answer. So here's QR along here. If you were to try and do the right hand slap pull on that, you'll have your fingers going this way again, the field lines, and the force, the current is also going that way. Your thumb would have to go that way, and that makes the right hand slap pull invalid. The thumb, or the current in the fingers, the current in the field lines must be perpendicular to each other. So it's 0 newtons. This is worth 2 marks, so one for the answer, one for the reason. Put it as a dot point. Current in QR and field lines are parallel.